Okay, so obviously went through all that yesterday. Today we are on to arc length and area of a sector, so I'm going to review those formulas really quick for you. Arc length is S is equal to R theta. Theta must be in radians. If it's not in radians, you have to convert it from degrees to radians. And then area is A is equal to 1/2 R squared theta. Or sometimes once you found arc length, people will rewrite it as area is equal to 1/2 RS. So let's look at number 32. R is equal to 4 inches and theta is equal to pi over 6. So we just plug in. So we'll have S is equal to R times theta. This is in radians, okay? It's in terms of pi, so it's in radians. So it'll just be 4 times pi over 6. And you will give decimal values for these. So let's see. 4 times pi divided by 6 is 2.09 inches. And make sure with these you don't forget units. And then area, I usually, since I've already found arc length, will go ahead and use this modified formula. And so area is equal to 1/2 times R, which was 4, times S, which was 2.09. Now use the value that's already saved in your calculator when you do this. So like just take for your answer from the previous and then multiply it by 4, divide by 2. And so your area is 4.19 inches squared. And I've obviously rounded both of those answers. Any questions about how we did that or anything with the more basic one? All right, let's look at one then that theta is not in radians, so we can review converting. So 34, R is equal to 15 centimeters. Theta is equal to 45 degrees. So before I do anything, I want to convert theta to radian. So what is my conversion factor for that?
35 over, then the pi
Pi
to the
over
right,
180 degrees.
Pi over 180, yep. And so again, we leave the pi's when we do this, so we're just reducing. 180 divided by 45 is 4, so this ends up being pi over 4. And again, if you recognize like 45 degrees is one of those values that's on your unit circle, so if you had that in front of you, you wouldn't even have to show the conversion. You could just rewrite it as pi over 4 just from looking at your unit circle. That would be fine. So, then we can proceed with arc length and area. So S is equal to R theta. So S is equal to 15 times pi over 4. So 15 times pi divided by 4 is 11.78. And that wasn't centimeters this time. So that's arc length. And then area is 1/2 RS. So 1/2 times 15 times 11.78. So I'm using what was already in my calculator for this number that wasn't rounded. And that comes out to be 88.36 centimeters squared. So probably goes without saying, but the most common mistake in these problems is not converting theta to radians. And typically, at least one of the problems on either the quiz or the test will be in degrees where you need to recognize to convert it. And a lot of times people don't convert it. Last year it cracked me up. I think it was last year. Before I handed out the test or quiz, whatever it was, I said, what does theta have to be in for arc length and area? Everybody was like, radians. Great. And over half the class didn't convert it. So, ingrain that in your brain. It's got to be in radians. Let's see. The next one say to evaluate the trig function using a calculator if necessary. If it's a value that we've already filled in on the unit circle, you need to just use the unit circle and give me the exact value off there. I'll show you what I'm talking about in a second. If it's not a value that you know, like if it was the sine of pi over 18, you will type that in your calculator. But I'll have to show you how to do that as well. Actually, all these are in radians, so yeah. Well, I'll also have to show you, but so let's look at 40. The sine of pi over 4. So I'm going to go over to my handy dandy unit circle. So sine are y values. Okay. So y value is the square root of 2 over 2. So this is equal to square root of 2 over 2. So that's what I mean by exact value. If it was something that we didn't know, you would just put it in your calculator and get a decimal. Let's see, the next one, 42, is secant of pi over 9. Now, are either of those two things something that's on your unit circle? No. So secant's not on there, and pi over 9's not on there. So I'm going to need my calculator. So look at your calculators if you have them handy, and tell me if there's a secant button on your calculator.
No. I don't think so. No, that's okay.
So if it's not a value that I know, and there's not a secant button on the calculator, what do you think I might need to do?
No solution.
Nope.
Find the cosine and flip it.
Okay, yeah, find the cosine and flip it. So we're going to rewrite this to put it in our calculator as 1 over the cosine of pi over 9. Okay, because that's what flipping it would do. Okay, is by putting it over. So 1 over cosine. So you'll type, no, back up before you go too far. Click mode on your calculator. Because this is pi over 9, this is in radians, your calculator has to be in radian mode. I think the other day, whatever we were doing, we talked about it needed to be in degree mode. This is where you have to get used to changing back and forth, okay? This one's asking specifically for, or it's not asking, but it's in radians. If you don't put it in that way, you're going to get a different answer. So you need to arrow down. For me, it's the third thing down, and you need to wait till it's blinking on radian and hit enter, and then you can just hit second quit and then go type it in. So it'll be 1 divided by cosine of pi divided by 9. Oh, not tangent. So then 1.064, or so 1.06 would be the value for that one. Did everybody get that? So then 44, cosine of pi over 6. So is that a value off your unit circle? Or pi over 6 is on your unit circle?
Yes.
Okay. So cosine values are x values. So we come over here. Cosine of pi over 6 is root 3 over 2. So square root of 3 over 2. And the last one that we'll do, and then we're done with this section, is 46. I've got the cosecant of 4 pi over 15. So any suggestions on what to do with this one?
Find 1 over the sine of 4 pi over 15.
Yep. So 1 over the sine of 4 pi over 15. So you'll type it in the same way you did the cosine one. And it should be 1.35 when you round it. That's what we got. Okay, so then the problems, let's see. So in addition to what you had yesterday, I'm adding on 33, 35, 39, 41, 43, and 45. So I know we didn't do a cotangent problem like this, but cotangent would be the same thing as like 1 over tangent. So just when you get to that one. Yeah.